Right, so we're trying to take the moment of all forces about point A. So we've done that for the UDL. There is 10, the value of the UDL times the span 3 times the distance from the midpoint of the UDL to this point A. That is 3/2. Okay. And now the direction. As we said, clockwise moments are positive, counterclockwise negative. So looking at this force taking us about point A, you see the direction is what? In the clockwise direction. So we leave it to be positive. So next force we have 5 kilonewton concentrated force. So we have what? 5 times what? What's the distance? Perpendicular distance to point A. That is 3 meters. And that one also, about point A, it takes us in the clockwise direction. So it's also positive. So you have plus. Right. So next, we have the reaction By. So the perpendicular distance of By to point A, that is from point B to point A, is what? 2 plus 3. So that's 5 meters. So the moment due to By will be what? By times 2 plus 3, 5. 5. And now what's the direction? How does it take us about point A? So we are at point A, and the force is taking us in the counterclockwise direction, isn't it? So that means that this would have given us negative moment. Okay. So it means that we have all the forces covered. So we can equate all to what? 0. So once we have this equation, our next step would be to find the unknown. And looking at this equation, let's call it equation 3. So the unknown is the By, the reaction. So By would have given us, when you do your computation, By is equal to 12 kilonewtons. Okay. So once you find your By, you could put By into what? Your equation 2. Into this equation to get Ay. And that one too would have given us 23 kilonewtons. Okay. So it means that we have all the reactions. That is, we're saying that Ax equal to 0. We found By to be 12, and we have Ay to be 23. So always, once you found your reactions, it's always good to cross-check. And by cross-checking, you would want to find moment about a particular point. In fact, it could be any point, such that you have the moment to be equal to what? 0. Because once your equations are right and your reactions are found to be right, so it means that your body, your beam, is in equilibrium. So if you take moment about any points, you must get 0. Okay. And even if you sum forces, either in the vertical or in the horizontal direction, you must get 0 also. Okay. So let's start with let's check. By doing that, we'll pick moments about a point. So let's say point C. So about point C, so first of all, we'll have these forces to the right. So By, we could write By equal to what? 12 kilonewtons. Ay equal to 23. So let's sum moment about C. So to the right here, we have 12 kilonewton, and that is in the counterclockwise direction. If you are at point C and you are rotating this force upwards, so it means that it's taking us what? The beam is rotating the beam in the counterclockwise direction. So we're going to have what? Negative 12 times the perpendicular distance, the distance from point B to C, 2. So next, let's look at the forces to the left. So to the left hand side, we have this force 23. Okay. That's the reaction AY. So we have 23 times the perpendicular distance AY to point C is what? 3 meters. So we have 23 times what? 3. And looking at this two is pointing upwards, so it kind of rotates. It will try to rotate this beam in the what? Clockwise direction. So that means that 23 times 3 is positive. Okay. Next we have this UDL. So the UDL is facing downwards, so taking us about point C, it will try to rotate the beam in the what? Counterclockwise direction. So we expect to have what? Minus 10 times 3, and of course times the distance from the center or the centroid to point C. So that's what? 3 on 2. Okay. So when you compute all this, we would get 0. You would get 0. So once you have 0, it means that the reactions that we found are all correct.